Hi everyone, so in this video I'm going to be showing how to do a backwards enamine reaction. So the previous video we did a forwards enamine reaction, and in this one we're going to do it backwards because I feel like the backwards looks kind of tricky at the beginning, but after you get past the first couple steps it looks the exact same as if you're doing an imine backwards reaction. So to start, I know that I'm working with an enamine because there is a double bond between the carbon next to the nitrogen and the carbon adjacent to that one. And an imine is characterized by a carbon-nitrogen double bond, but an enamine does not have a double bond between the carbon and the nitrogen. It has a double bond between what originally was the carbonyl carbon and the carbon that is next to it. So that's why going backwards, this first step is a little bit tricky, but from the previous videos, I know that after I have my product in front of me, and if I'm going backwards, the first thing I need to try to make is my hot electrophile. So this step is the tricky step, but once you get it down, everything else makes a lot of sense. So in order to form my hot electrophile, I know that I need a double bond between the carbon and nitrogen. And the way that that forms, just kind of happens spontaneously, so to speak, is that the lone pair at my nitrogen will fold over and form a double bond. Boom. But I know that I can't have two double bonds on the same carbon, so to break this double bond, it will grab a hydrogen from my solution. It could be from water, it could be from the acid itself, and then I will have my hot electrophile. So I'm going to draw my hot electrophile where I have my nitrogen double bonded to my what will be my carbonyl carbon, and then the rest of the molecule stays the same. So I have this, this, and this. So this is pretty much the hardest part of the reaction, and everything else looks about the same. And I know that I have my hot electrophile because my nitrogen is double bonded to what will be my carbonyl carbon, and it's positively charged. Since this is a hot electrophile, I know that now my nucleophile in the backwards direction, water, is going to come in and attack what will be my carbonyl carbon. So the oxygen will come in, attack this carbon, cause this double bond to break, and give my nitrogen back a lone pair. So I'm going to draw my, oops, that's ugly. I'm going to draw my new molecule down here where I have my nitrogen, what will be my carbonyl carbon. I'm going to draw the rest of my molecule. But now this carbon has a new nucleophile onto it, and it has the water on it. So I'm going to draw my water over here. And I also know from this carbon, the original molecule, that this carbon also has a hydrogen attached to it. It's just not drawn. So I'm going to put a little hydrogen right there just to remind us that now this is an sp3 carbon and originally it was an sp2 carbon. And we don't always draw hydrogens because organic chemists are a little bit lazy and they don't feel like drawing hydrogens. So now that I have broken my hot electrophile, I know that I'm trying to get to my hemi state. But I can't do that when I have an unhappy oxygen. So to make my oxygen happy, I'm going to deprotonate it, or something in my solution is going to grab onto a hydrogen and then make my oxygen happy. So I'm going to redraw my molecule. But now my oxygen is happy because it just has the one hydrogen on it instead of two, and now I've reached my halfway point where I have my hemi. Since I know that I'm trying to reform the carbonyl, I know that I'm trying to get rid of my nitrogen molecule. I'm trying to make this whole thing fall off. And the way that we've been doing that before, and the way that we will do it again, is to protonate the nitrogen. So I have a lone pair here that's going to grab onto the hydrogen in a water molecule or something, who cares? And then I'm going to redraw my molecule showing that my nitrogen is unhappy. And the reason why it's unhappy is because it has 4 bonds and no lone pairs, giving it a positive charge. So now my nitrogen has a reason to leave. This carbon-nitrogen bond has a reason to break because my oxygen is going to use one of its lone pairs to fold over and form a double bond. And then this carbon-nitrogen bond will break, causing the whole NCH3 and the CH3 over here and this hydrogen to just fall off. So now I'm forming my carbonyl, reforming my carbonyl. So I'm going to put the latter half of my molecule here. This is I'm going to number my carbons really quick. 1, 2, 3, 4. 1, 2, 3, 4. And I know that my double bond just formed between my one carbon and the oxygen that it was attached to, but all of this is now gone. So I'm going to draw my carbonyl going off to the side right here to make my IUPAC happy, and to put my carbonyl right here. And I know that since this carbon had a hydrogen on it that we didn't draw because we're lazy, this carbon had a hydrogen on it, and this carbon still has that same hydrogen on it, that means that my number one carbon, the other substituent on this carbonyl, will be a hydrogen. And I recommend drawing it because we always want to represent our sp2 carbons as trigonal planar. We want to draw all three substituents. We don't really feel that way for tetrahedral carbons because we're lazy. So now I have my carbonyl carbon formed, but this oxygen still has a positive charge on it. And now my nitrogen is in solution and it's happy because it has 3 bonds and a lone pair. So the last step in the reaction is to make my oxygen happy. So I'm going to have something in the solution come and grab a hydrogen, giving an oxygen back its lone pair, and then I have my final product. So I have my carbonyl, and then I have my 1, 2, 3, 4, bear with me, 2, 3, 4. My 2 carbon has a substituent, my 3 carbon has a substituent, and my carbonyl carbon has its oxygen substituent, the 1 on its right, and then hydrogen over here. And this is my final product. So I feel like the hardest part about the enamine backwards reaction is really this first chunk, is really recognizing what in the hell is happening. So forming the hot electrophile here, we knew that we had to have a double bond between the carbon and the nitrogen and its positive charge. That's what makes it so hot, LOL. So in order to form this double bond, we had the lone pairs in the nitrogen fold over, which makes this double bond need another substituent, so it grabs a hydrogen, and then we have our hot electrophile. And then the reaction pretty much looks the same as it did before for the imine backwards reaction, where we had to give a reason for the nitrogen to leave, so it got protonated, and then once it's protonated, we can reform the double bond for the carbonyl, kicking this entire thing off as a leaving group. And this is what it looks like as a leaving group. We reformed our carbonyl carbon, but it's still bonded to that hydrogen, so something else in our solution, probably water, is going to come and grab that hydrogen, giving us a happy product. So I recommend doing this reaction going forwards and backwards one more time, and then you'll for sure know that you know how to do it. So I hope this video helped, and let me know if you have any questions.